Alright, now that we've finished with paste, let's talk about bash arrays. Arrays are declared with an open-close paren. The contents are white space separated as seen here. Bears beats Battlestar Galactica. Here's a typical way to echo the entire contents of the array, but you should know that there are other ways as well. If you want the third item in the array, you index into it with square brackets. If we wanted to know the number of characters at the third index, we just add the pound symbol in front. If you want to know the number of items in the array, use the @ symbol instead of an index. And you can append to bash arrays using +=. Although bash has really poor support for multi-dimensional arrays, you can attempt to slice. Here we see EA from bears, which is at the first index, not the 0th. You can also find and replace patterns in place for the array. I've used this trick for a couple programming challenges. Bears beats Battlestar Galactica bash. If you want to loop through each item in the array, you can do so with a for loop as seen here. Newer versions of bash support associative arrays, which are a lot like Python dictionaries. So we must declare the array associative for this to work. The item in brackets is the key, and after the equal sign is the value. And here's how you get the value associated with a key of moo. If you mistakenly attempt to use a value that isn't a key, you'll get an empty line. And again, we get the value dog from the key woof. So let's make files f1 and f3.txt if we don't have them already. You should have x2.txt filled with column values from my second bash video. So now let's talk about the wildcard. If you type ls wildcard, you are essentially LSing on each file in the directory. This doesn't look much different right now, so let's change that. We'll create some directories in our path using makedir, and we'll use curly brace expansion. But to create paths deeper than a single directory, we need to use the -p flag. So now ls wildcard performs ls on the subdirectories, and we see the first level of directories. If you wanted to list a subdirectories, you could type ls */*. But what if you're looking for a file? This definitely wouldn't be the quickest way to locate it. So let's create a couple of files randomly hidden in our subdirectory tree. So you should know bash has built-in variable called random that generates random numbers. So we'll use this to create some random files. It's interesting to note that you can store the contents of listing the subdirectories into an array. This is useful for counting the number of files. But this method only works 3 levels deep. As well, you can see in the file paths there are colons, and we don't really want that. So instead, we'll use find. But first, let's clear the contents of the array so you know how. It works just like unsetting variables. And if you run the last command, you can see, indeed, the array is now empty. So let's use find to drill down into directories that are present below subdir. And now you can see those cluttersome colons are no longer present. So now we can create a random number that is within the range of the number of files available. And we'll grab a random path to add to the random files. So let's make an example for known and unknown file names. Somewhere in our subdirectories, we will create a file called random.txt. And then we'll create a file of which we don't know the name. As you can see, using ls with multi-level wildcards is honestly too much output to sift through manually. We could use this convention and grep to find the file, but the method shown here, you must know the file that you're looking for. Additionally, it doesn't give the path, so we don't know what subdirectory in which the file is located. If the file is located further than 2 subdirectories deep, our grep solution wouldn't work. Instead, we should use find. As you can see, the entire path to the file is displayed by default. If you don't know the file name, but you know the file extension, you could grep for the file extension. But possibly a better way would be use find's type flag. So we see here, both the known and unknown files were located.